Welcome to Maths and Science by IITian channel. In this lecture, this is the 6th lecture on rotational motion. In this lecture, we will be discussing about the kinetic energy by the rotation of the rigid body about an axis. This is the axis of rotation. This is the axis about which the body is rotating. Below x-axis, I have given only mirror image. Above it, body is there. It's a rigid body. Let us say it's rotating like this. In this direction, rotating. And it's rotating with a angular velocity of omega. And for this shape, for this particular shape and mass, I is equal to moment of inertia. Then kinetic energy is equal to half I omega square. This can also be written in physics as T. T is equal to kinetic energy is equal to half omega square. That's what we have to prove. This is the situation given, and this is the rigid body. In the next slide, I have shown for 10 seconds the motion of this rigid body. For 10 seconds, I have shown a video how this rigid body is rotating about the axis of rotation. And what happens to different particles? Let us say it is a rigid body is a collection of particles. Let us say it is M1, one particle, and another particle is M2, another particle is here M3, M4. Like this, infinite particles are there. These are all rotating together with a angular velocity of omega, and the distance from the axis of rotation, this axis of rotation is passing through this point. Because axis of rotation should pass through certain point, let it be this point. From this point, what is the distance? This is R1. Let this distance be R2. Let this distance be R3. And let this distance be R4. These are all the distances from the axis to the particle, and there are infinite number of particles, and the velocity with which each particle is moving, this M2 is moving perpendicular to this V2, M1 is moving perpendicular to this R, that is V1, like this. Because omega is this way it is V3, this way it is V4. Like this, all the particles are moving. There are infinite number of particles, and this rigid body is moving. Then we have to find out what is the total kinetic energy of the rigid body. Individual particles are given like this, and I have shown in the next slide, as I told you, rather a 10 seconds video, how this particle is moving around, rotating around the axis Y. Now, by this time, you might have seen the video, and if we take a rough sketch, it is not to scale, of the rigid body of this type which we have taken, and this is the axis of rotation, and this is the x-axis, below which is the mirror image. M1, M2, M3, M4, M5, numerous number of particles are there, and for each particle the distance from the axis is this. This is O, origin, because in physics everywhere we require an origin or reference, without reference frame, including reference frame. Don't bother about the lines what I am drawing. Try to understand the concept. Now, this is R1, this is R2, this is R5, this is R4, this is R3 distances. Then how will be the velocities? If omega is this way, the velocity is perpendicular to this R. The circle curve is there, tangent to the curve. This is the curve. How this is moving? Tangent to the curve. This is V1, that I have already shown you in the previous class. This is V2, this is V3, this is V4, this is V5. Now, from the definition of the kinetic energy, kinetic energy of a particle is equal to half m v square. What is V? V is equal to omega r. You know the vector of velocity is equal to omega cross r, which I have already explained you in the previous classes. Now, kinetic energy of a particle, it is also velocity of a particle, where omega is the angular velocity, r is the distance from the radial distance, from the point under consideration, from the axis to the particle. Now, then kinetic energy of rigid body kinetic energy is equal to sum of the kinetic energies of individual particles. That is equal to sigma half m vi square. V1 square Vi square. When you put the sigma, it should be Vi square. That is nothing but half mi here, because each particle will have a different mass, need not be same mass. m1 v1 square plus half m2 v2 square plus half m3 v3 square plus so on. Now, kinetic energy of a particle, of individual particle, is equal to half mi vi square, because it can be m1 v1 square, m2 v2 square for particle 2, for particle 3 m3 v3 square. But velocity of each particle vi is equal to omega. Omega of the rotational angular velocity of the rigid body is same for all the particles. It is not changing. Omega will not change. Omega Ri. Radial distance is changing for each particle, as you see, R1, R2, R3, but omega is not changing. For the whole body, omega is same. Now, then kinetic energy of rigid body is equal to sigma half mi vi square is equal to sigma half mi is same and vi is omega ri whole square, omega r. Since vi is equal to omega r. This is equal to sigma half mi omega square ri square. When you take out omega square out, because omega square and half are constants, they do not change for each particle. Half omega square sigma mi ri square. From the definition of the moment of inertia, moment of inertia of a particle is equal to mass of the particle into distance square, that radial distance square of that particle from the origin from where you are considering reference, from the reference, like this. It's everything is like you think about the vector. This is the particle P, this is R. This is equal to m small r square also. Capital R square, small r square, whatever you want to write. mr square. Now, this mi square is equal to moment of inertia of each particle, each individual particle. But moment of inertia of the total body is equal to moment of inertia of total rigid body. I want total rigid body is equal to sum of the mi's of individual particles. Therefore, moment of inertia of rigid body is equal to sigma mi ri whole square, mi ri square. That is equal to capital I. This is for the whole rigid body. Hence, kinetic energy, what we have derived just now, kinetic energy is equal to half omega square sigma mi ri square. Kinetic energy is equal to half omega square sigma mi ri square. That is equal to half omega square into I. That is equal to half I omega square. Therefore, if omega is known and the moment of inertia of the total body is known, then we can find out the kinetic energy of the body, rigid body. Kinetic energy is equal to half I omega square. This derivation is given as a question in various universities, examinations, and also in UPSC. For that only I have derived this derivation. This question is directly asked. Hence, kinetic energy of a rigid body is equal to half I omega square. Same kinetic energy, it is in the rotational motion. In a linear motion, kinetic energy is equal to half mv square. This is in linear motion. Here, v is the linear velocity, v is the linear velocity, omega is equal to angular velocity, angular velocity is radians per second, linear velocity is meters per second, SI units. And m is equal to here mass, that is in kg, and I is equal to moment of inertia, that is equal to kg meter square. This is what is the lecture about deriving, finding, deriving or understanding the kinetic energy of a rigid body and comparing it with the kinetic energy formula of the linear velocity, linear motion with the angular motion. I want to stop this lecture with this. In the next lecture, I will be moving forward to find out work done by torque. What is torque? Torque and work done by torque. That is in the next lecture I will take up. Best of luck to everybody. If there is a value addition because of this lecture to your knowledge, kindly share and subscribe to my channel. Share and subscribe to my channel, Maths and Science by IITian. And the video of 10 seconds, if you want, you can recollect it and understand how a rigid body rotates about an axis of rotation. And thank you for viewing my lecture. Best of luck to everybody in your